Okay, for day 2, I want to talk to you about something called Pascal's triangle. So day 2 is expanding on our combinations from day 1. So to form Pascal's triangle, we're going to form it using combinations. And so we want to know how many ways we can select 0 things from 0 objects. Well, there's only one way we can do that. So this is row 0. So n equals 0. For row 1, we want to know how many ways we can select 0 things from 1. There's one way we can do that. And how many ways we can select 1 thing from 1. There's one way we can do that. So then for row 2, we're going to do the same thing. And so if you're not catching on to the pattern here, how many ways can I choose 0 things? How many ways can I choose 1 thing? How many ways can I choose 2 things? That's what I'm filling into the next row. So there's one way I can choose 0 things. There are 2 ways that I can choose 1 thing. And there is 1 way that I can choose both of those things if I have 2 options. Same thing for n equals 3. There's 1 way I can choose none of them. There are 3 ways I can choose 1 of them. There are 3 ways I can choose 1 of them. And there's 1 way that I can choose, or that I can choose 2 of them, and there's 1 way that I can choose all 3 of them. Now, I'm going to keep going with this, and what I want you to know is I'm not using a calculator for this, and I don't have it memorized. I want to see if you can see the pattern that's forming here. For row 4, there's 1 way I can choose none. There are 4 ways that I can choose 1. There are 6 ways that I can choose 2. There are 4 ways that I can choose 3, and there's just 1 way that I can choose all 4. I can keep going with row 5. 1 way, 5 ways, 10 ways, 10 ways, 5 ways, and 1. Hopefully you're starting to see this pattern emerge, and you may be seeing some different things, like all of the outsides are 1s. And then you see the next diagonal in is counting up 1, 2, 3, 4, 5, but you may not be seeing where the 6 and the 10 are coming from. What I want to point out to you, if you're not seeing this pattern, is that I'm using the previous row to get to the next row. So here, 1 plus 1 is 2. 1 plus 2 is 3. 3 plus 3 is 6. 4 plus 6 is 10. That works everywhere in this triangle. And so all we're doing is adding those 2 and bringing it down on that diagonal between them. And that forms this triangle. That's a very cool thing. If you don't have a calculator, that tells you what those combinations would be. And so here's a more filled out table. If this is easier for you to see, you can see Pascal triangle as combinations. 0, choose 0, 1, choose 0, 1, choose 1. And then you can see the triangle formed from there. It matches this triangle as well that we just formed. And you could continue on with those rows then using our same methods. So the 6 members of a model UN club must choose 2 representatives to attend a state convention. Use Pascal's triangle to find the number of combinations of 2 members. So we want to find in Pascal's triangle where we have 6 and we select 2. Well, that would be this next row. 6, choose 0, 6, choose 1, 6, choose 2 would be right here. So I know I have 1 here, I have 6 here, I have 15 here. So that tells me then 15 would be my answer. So that's how you could use Pascal's triangle to find those combinations without multiplying out in your calculator. Okay, so I want to take you back to something that we learned about before, and I want to remind you of these before I show you the pattern here. So, this is x plus y quantity squared, and so to remind you, this would be x squared, and then it's 2xy, and then it's y squared, if you have forgotten that. Now this one, we talked about counting up and counting down to help us remember what goes where, but this is 1x to the third plus 3x squared y plus 3xy squared plus y to the third. So now if you look at this and think back to the triangle, if you look at where n equals 2 in the triangle, you should see that the coefficients are 1, 2, and 1. If you look at this one, if you look for where n equals 3, the coefficients are 1, 3, 3, and 1. So that's the next row. So this helps you to find those coefficients that belong out front there. And then you notice that with our x values, we start with an x to the third, and then we drop down a degree every time. So we go to x to the second, and then we have x to the first, and then we have x to the 0 or no x's. With y, we do the reverse from left to right. We have y to the 0 or no y's, and then we have y to the first or 1y, y to the second, and then y to the third. So that rule is up here in the binomial theorem, and that says a plus b to the nth power. Well, we use n combination 0, and then a to the nth, b to the 0. And we use n combination 1, and then we drop our degree of n by 1, and we add 1 to our degree of b. And we continue on until we get all the way to the end. So use the binomial theorem to expand. Well, the third row tells me we're going to use 3 combination 0, and then I'm going to take my x squared, my x term, and I'm going to take it to the nth power. So I'm going to take it to the third power. And then my y term, I'm going to take to the 0 power, or it's not going to be there. So then I'm going to have 3 combination 1. And I'll have x squared as my first term. And I'm going to drop that down, so it's only going to go to a power of 2. And I'm going to bring my y term up to a power of 1. And then I have 3 combination 2. I have x squared to the first, and then I have y to the second, and I have 3 combination 3, and I have x squared to the 0, and y to the third. Now, as you get more comfortable with this, you may not have to write out all of these things. But I know 3 combination 0 is just 1, and then x squared to the third power, 2 times 3, then I have x to the 6th. 3 combination 1, that's 3. And I have x squared squared, that's x to the 4th. And then I have y to the 1st. 3 combination 2, that's 3 again. And then I have x squared to the 1st, and then I have y squared. And then 3 combination 3, well, that's 1. X squared to the 0, that's 1, so that's not there. And then I have y to the third. Now, you don't have to have those coefficients of 1, but that's your answer. You have essentially multiplied all that out without doing all of that foiling and multiplying, if you understand how that binomial theorem works to expand. So then we can do the same thing with 4 here. So I know if I need to go back and look at my triangle, or I can recreate my triangle, I want to look and use 1, 4, 6, 4, 1 are going to be my coefficients. So for my first one, I know that I'm going to have 1 out front, and then I'm going to have my first term to the 4th, my second term, which I'm going to put as negative 2b to the 0. It's really not there. And then I'm going to use 4, and then my first term drops down a degree to 3. My negative 2b picks up a degree of 1. And then it was 6, and then my first term drops down another degree to 2. My negative 2b term picks up another degree of 2. And then I have a coefficient of 4. First term picks up another degree. First term drops another degree. I'm moving the wrong way. So it was a 2, now it's a 1. My second term picks up another degree. And then I have 1 coefficient. My first term drops another degree. I'm at 0. That's how I know I'm done. And then my next term picks up another degree. So then I have negative 2b to the 0 just cancels. The 1 can be there or not. So I have a to the 4th here. And then I have negative 2b to the 1st. So I know that that's negative 2 times 4. So I have negative 8. Then I have a to the 3rd, and I have b. So I did a little rearranging there as I combined. Now I have negative 2b squared. So negative 2 squared is positive 4 times 6. That's a positive 24. And then I have a to the 2nd, and I also have b to the 2nd. The next one, actually I have a negative 2 to the 3rd, so that's a negative 8 times 4, so that's a negative 32. I have a to the 1st, and then I have b to the 3rd. Then I have negative 2 to the 4th, which is a positive 16 times 1 is just 16. A to the 0 is just 1, so I don't have to write it. And then I have b to the 4th. That's your final answer here. Okay, so then this last one says, find the coefficient of x to the 4th in the expansion of 3x plus 2 to the 10th power. So we want to know where we have x to the 4th. We know it's going to look like 10 combination something. We need our 3x to go to the 4th power because we need our x to the 4th. So then we need our 2 to go to something. Now what I want you to notice in all of these is you're like looking back up at number 2 in the red, that this 3 and this 3 match, this 2 and this 2 match, this 1 and this 1 match. So I need to figure out what number goes in for that exponent of 2 and what number goes in for that combination. So what you also should notice is that those exponents add up to 3. If you're looking at that red, 3 plus 0 is 3. 2 plus 1 is 3. 1 plus 2 is 3. And 0 plus 3 is 3. So in this case, we need to add up to 10. So if I know that this first one has to be 4, then I know the second one has to be 6. And so I'm using 10 combination 6. So that's something probably just going to go straight to the calculator to type in, because unless you want to expand your triangle that far, that's a little much. So that's 210. That's not your exponent, because we also have times 3 to the 4th, which is 81. And then that's x to the 4th still. And then we also have 2 to the 6th, which is 64. So still not done, because we need to do 210 times 81 times 64. So our coefficient here is going to be 1,088,640. And it would be x to the 4th, but since it's asking for coefficient, all we care about is the number in front of the x to the 4th. So our answer really is just what's in the box. All right, guys, that's all I have for you today. If you have questions, please come in and see me. Otherwise, I will see you in class.